today is solving a system of equations. We've already discussed what a system is. We've talked about some of the special cases when dealing with systems. And so I'm going to show you two of the three methods that we use in Algebra 1 for solving systems of equations. The first method is graphing and the second is substitution. The other day you guys looked at some of the steps for both of those two methods, and so now I'm going to walk you through some examples that shows you how to do it in the context of here's one method versus the other. Once I start the other video that you guys are actually going to be watching, I'm not going to have the camera on. That way you guys can just kind of focus on what I'm doing and not necessarily my face down in the corner. See you guys later. So again, the title of this lesson is Solving a System by Graphing or Substitution Method. The objective is to be able to determine what the solution is for using either one of those two methods. Alright, so this is what the page in your notebook looks like. Please do not forget to complete your notes as you're watching the videos. So the method that we're actually going to start with is substitution. And so we're looking at the first example where the system that you're given is y equals 3x plus 2 is the first equation, and negative 4x plus 2y equals 8 is your second equation. So what we're going to do is we're going to take that first equation, because that one is already solved for the y value, or the y variable. So we're going to take that one and plug it into the second equation. So substitute the y in the second equation. So we're going to take 3x plus 2, which we see right here in the first equation, and we're going to replace this y right here in the second. So I've given you the steps here because this part goes back to substitution that we did at the beginning of the school year. So if you need a recap on that, please look back in your notebook on how we actually kind of work through all of those steps. So once we work through solving the equation, we find that x equals 2. So we're going to take that value that we got right there and we're going to plug it back into either of the equations. In my opinion, again, either one would work. My opinion is the first equation is going to be the easier of the two to plug into. So I always make sure I look for the easiest equation to plug into that requires the least amount of work. Alright, so y equals 3x plus 2. We substituted the 2 into the equation where the x is. 3 times 2 is 6. 6 plus 2 gives us 8. We always have to make sure that we write the solution to the system of equations as an ordered pair. Remember, an ordered pair is x then y. And the second method that you can use when solving a system of equations that we're going to start with in this little video is graphing. You can graph all of this by hand. We've done that for the past month or so. So you guys are very familiar with how to graph and the process. So the first equation is y equals 3x plus 2. That was in slope-intercept form. So I started by graphing my y-intercept, which is 2, and then using my slope, which is rise over run. So 3, up 3, and over 1. And that's the black graph that you see. And then the second equation was negative 4x plus 2y equals 8. And for that one, I found my slope and y-intercept. No, I'm sorry. I found my x and y-intercepts and graphed those. The graph that you see that just came on the screen is Desmos. So I went into Desmos, graphed it, and put that here. And that's, of course, a much nicer, neater graph. But let's make sure that you know how to do it. I'm going to show you those steps here. So I'm going to show you guys how to graph a system of equations in Desmos and what that's going to look like when you graph it. So we've already learned how to put the equations in there. So I put my equations in the first and second row. And so this is the graph that it gives me. The point of intersection is right here. This is where they overlap. And if I click on that point, it'll tell me, if I hover, that that's at 2, 8. If I click it again, that point becomes permanent, and the order pair is 2, 8 for when I'm graphing it using Desmos. Alright, so that's it for the first example. I showed you how to do it by hand for graphing as well as how to do it in Desmos. And that takes us to our second example on graphing and substitution. This one I'm going to jump right into showing you what the graph looked like when I put it into Desmos. So the point of intersection for the second example is 5, 4. And here's where I walk you through solving it algebraically using the substitution method. Alright, so for this example, this second example on substitution and graphing, I'm going to start with the substitution method, and I'm going to start by showing you how to solve one of these equations for y. My recommendation is if you have a system where none of the coefficients, and remember the coefficient is the number in front of the variable, if none of those coefficients is a 1, so if you don't have just a variable by itself, don't use substitution. Find a different method, either graphing or elimination, or if you're more advanced and you get into the matrices and those kind of things, choose one of those methods. Do not get bogged down in this process with substitution if none of the coefficients is a 1. But I am going to show you how to do it so you have the knowledge and you would have seen it before. But in the future, if there's a coefficient in front of all of the variables, find a different method. So we're going to start first by choosing one of our equations, and it really doesn't matter in this case which one you choose. You're going to choose one of these equations and you're going to solve for y. Or I guess you could solve for x. Let's solve for x. Alright, so let's use this second equation right here. So we're going to solve for x. So 3x, we're going to move that y to the other side so it becomes 4y minus 1. And we're going to divide by 3. So x equals 4y minus 1 over 3. And things are going to get a little more interesting from there because we are going to be plugging in that fraction. So we're going to plug that fraction into the first equation, which was negative 3. We're going to substitute for that x as 4y minus 1 over 3 plus 7y, and that whole thing equals 13. Alright, so now we're going to deal with the negative 3 and the 3. I'm actually going to cancel those out and make that a negative 1 times 4y minus 1 plus 7y equals 13. Because 3 divided by 3 is 1, and we have to keep the negative sign so it becomes a negative 1. So we have negative 4y plus 1 plus 7y equals 13. We're going to combine like terms. Our two like terms in this example is going to be 4y and 7y. So negative 4 plus 7 gives us 3y plus 1 equals 13. Subtract the 1 from both sides. And you have 3y equals 12. And after we divide, our y value is 4. Now that we have that first value, we're going to use that to plug back into one of the equations we have. And technically in this case, we have 3 equations. If I get my screen to cooperate and go back to the previous slide. Alright, so we have this one. Those are our 2 initial equations. We also have this one right here that we made. So we actually have 3 equations in this case. My recommendation is always to plug back into one of the original equations. Just in case there was a mistake in your ability to rewrite the equation, I always say plug back into one of the originals. Alright, so I'm going to plug into the first one, so negative 3. Value for x. So let's take that part off. So negative 3x plus 7. Our y value is equals 13. So negative 3x plus 28 equals 13. And we'll subtract that 28 from both sides. So negative 3x equals negative 15. And because our goal is to get x by itself, we're going to divide both sides by negative 3 because that's the coefficient in front of x right now. So x is 5. So because our y value was 4 and our x value is 5, our final ordered pair for this problem is 5, 4. All right, so one of the things that I hope that you noticed as we worked through those two examples was that regardless of whichever method you use, the answer is still the same. So the method doesn't change the answer choice, or the answer solution, I think is a better word, is going to be the same as long as you work the steps correctly for either of those two methods.